Does your app need a way to send users to external URLs? Either to a web page or to send an email or even sometimes to a phone number? The URL package is for you. For example, opening a web page on a button press is as easy as calling a single method. You can also use the URL launcher with telephone numbers. This will start the phone's dialer app. Or you can initiate text messages, or even emails. Finally, if there are apps installed with special URL handlers such as YouTube, your app can launch into those apps. One last thing, you should always look before you leap. Make sure to call canLaunch to check if the device can open the URL, otherwise you might run into trouble. If you're coding with Dart, you've probably used the SDK's built-in async support for things like streams. But did you know there's also an async package with a bunch of useful additions? There's Stream Group, for example, which can merge several streams into one. Or try Async Cache, a class that'll give a cached result for repeated calls to a function within a specific time frame. There's also Stream Queue, which can turn a stream of data into a synchronous queue of futures. Sometimes, an app needs a place to put the legalese, the version number, the licenses, and all the other small print. In fact, some stores won't even let you publish your app unless it has all these formalities. You should not leave the creation of such an important part of your app until the last minute, of course, and we know you would never do that. But if you do, there's a widget for that. It's called About Dialog. You can build it and show it yourself, but most people will just call the function showAboutDialog, which does that for you. Just find a good place to call the function. An on-pressed or on-tapped callback of a tile deep in your settings page is the perfect fit. Then, just call showAboutDialog. You have to give it a build context, this will probably be the current one, and the rest of the arguments are optional, but without them, the show dialog doesn't show much. You can provide the version number, the application icon, and small print legalese. You can also put any number of additional widgets into a list of children, like so. Now your app looks more real, doesn't it? Also note that Flutter helpfully provides a View Licenses button. This button takes the user into an automatically generated list of all the licenses used in your app. These are the contents of the license files from all the packages that your app is currently using as collected by the Flutter tool. If you want to add a license to this list, you can. Just use the License Registry class from Flutter Foundation. And there you go, your due diligence is done and you can now ship your app like the pro you are. Whenever you accomplish something, it's rewarding to be able to check it off. There's never just one thing to do though, and these checkboxes usually come in a list. One option is to take the checkbox widget, compose it together with some other widgets, and pop it into a list. Suddenly this starts to feel familiar, almost like it's a tile within a list. This is a perfect place for the checkbox list tile widget. Textbox list tile combines two widgets, checkbox and list tile. But instead of simply making the leading or trailing widget a checkbox, it also makes it so that tapping anywhere in the list tile toggles the checkbox. The constructor for checkbox list tile looks suspiciously like a combination of checkbox and list tile. You provided a title for the text of the tile, and you use secondary to set what the widget on the other side of the tile should be. In a list tile, this might be the leading or trailing parameters, but in a checkbox list tile, one of those will always be a checkbox. You can control which side these appear on by using the control affinity property. Passing in list tile control affinity.leading, trailing, or platform will put the checkbox either in front, at the end, or whatever the platform normal is. Checkbox list tile doesn't maintain any state itself, and so you'll often find it within another stateful widget. That way, whether or not the box is checked can be maintained as a bit of state with the value property, and modified with checkbox list style's onChanged callback. Finally, if you don't like the default colors provided by your app's theme, you can override them with active color and check color. And there you have it, your very own list tile with a checkbox. In an app with lots of widgets, things often get crowded. Look at these boxes, they're basically on top of each other. While these boxes are social creatures, they could do with some distance between them. By using the padding widget, you can provide these boxes some space. Padding adds space around any and all sides of its children. Just take the widget you want to put space around and put it as the child of padding. Then, tell it how much space to give with the padding property. Passing in edgeInsets.all, for example, will put the same amount of padding around all sides of the child widget. EdgeInsets is an implementation of the abstract class EdgeInsetsGeometry, which padding uses to figure out where and how much space to apply. It starts by telling its child that the amount of space it can take up is constrained by however much padding was given, and then it fills the remaining space with nothing. EdgeInsets specifies the space along the cardinal directions, left, top, right, and bottom, and ignores the current text direction of the app. EdgeInsets Directional, on the other hand, gives the space in terms of the start and end. And that's it. Your widgets can now have the appropriate amount of distance between them, no matter how social they might be. There are many different options for animations, and sometimes all you want to do is animate a widget. In many cases, an animated widget is all you need to make a widget animated. Animated widget isn't exactly a widget on its own, as it's an abstract class, but it is a powerful tool in creating your own animations. There's some animated widgets already built for you. Look for widgets like slide transition, rotation transition, and other food transitions. But if none of those animate in the way you want, it's time to build your own. Start by extending animated widget. It requires two things. The first is a build method which returns the widget you want to have animated. The second is something that will notify your widget about updated values, like an animation. You can call that something whatever makes sense for your custom animated widget, but for the constructor, you'll need to pass it up to animated widget superclass as the listenable argument. Then, add a getter to make the listenable usable within the widget you're trying to animate. Finally, go back to the build method and use this value where it makes sense for your widget. Congratulations, you now have your own animated widget. You'll need some kind of animation to use this widget, and the easiest way to get one is to create an animation controller within a stateful widget. Make sure to initialize the controller in init state and dispose of it in dispose. Once you have that controller, you can now start, stop, or repeat your animation wherever it makes sense. Sometimes a picture or some other part of your screen looks too boxish. Look at all those corners. Ugh. Wouldn't it be better if that picture was a circle, like this? There's a widget that can clip its children to round circles and ovals, and it's called Clip Oval. Just take any widget, like the image here, and wrap it with a clip oval. By default, Clip Oval will take on the child's size, so this tall picture will be clipped by a tall oval. If the picture was wide, the resulting oval would also be wide. When the child is a square, then the oval will become a circle, because an oval that has the same width and height is a circle. But you don't need to fiddle with the size of the child in order to change the shape of the oval. Just add a custom clipper, and now you can customize the size to your heart's desire. You must implement the clipper as a new class that extends CustomClipper of rect and implements two methods, getClip and shouldReclip. The getClip method takes the size of the child and returns the rect into which Flutter will draw the oval. You can place the rect anywhere and make it any size. For example, here we're putting the oval to the top left corner of the child and limiting its width to 200 and height to 100 pixels regardless of the size of the child. The other method of CustomClipper, shouldReclip, just tells Flutter whether it must perform the clipping again given the previous state of the clipper. As a performance optimization, return false if you're sure that the state of the clipper would result in the same clip. That's it for Clip Oval. Just remember, this is Flutter and you have control of every pixel on every frame. Nothing stops you from animating Clip Oval over time for interesting effects.